Hello students. So this is our second lecture of light, chapter number 10, reflection and the refraction. And part 1 we have discussed about what is light, and we have learned that the light is a form of energy which enable us to see the objects around us. Then we have discussed about the nature of the light, and we have learned that the light have we can understand the nature of light by using 3 theories. One is wave theory, that which tells us that light do not need any kind of medium for their propagation. And secondly, we have learned about the second theory is particle theory, which told us that light is composed of particles, and these particles are known by photons, which travels in a straight line. Then there is a new theory, quantum theory, which tells us that light is composed of both wave and the particle. Then we have discussed about reflection of light. So we have learned that the reflection of light is a bouncing back of light. Bouncing back of light when light falls on an object. So it gets bounced back, and this is called reflection. And we have also learned we have also learned about some of the terminologies regarding reflection. We have learned about incident ray. We have learned about we have discussed about reflected ray. Also we have discussed normal. We have discussed angle of incident. We have also discussed angle of reflection. Clear? So what is incident ray? Let's take a quick revision. Okay, say this is a mirror, plane mirror, dash, and taken a source of light, say torch. From that torch, if a light ray falls obliquely, then this ray is the incident ray. And there, after falling, light will bounce back. This is the point where incident ray meet with the surface. It's called point of incidence. Point of incidence. And this ray that bounce back is called reflected ray. Then we have taken a ray which is perpendicular to the surface. We named it as normal. This angle between the incident ray and the normal is called angle of incident. We denoted it by angle I. And the angle between the reflected ray and the normal, we named it as angle of reflection, that is angle R. Clear? So from this we have taken a ray which is falling obliquely. Now what will happen if we take a ray which is falling straight? Now if a ray is falling this way, then the angle of incident is 0. So from the second law of reflection we have learned that then we have also discussed that there are 2 laws regarding reflection. Incident ray, normal, and the reflected ray are on the same plane, and angle of incident is equal to angle of reflection. So when a ray is falling like this perpendicularly, or when a ray is falling as a normal, so angle of incident it was 0. As to maintain the second law of reflection, what will happen? Angle of reflection will be 0. So when a ray falls on normal, as perpendicularly, what will happen? Light will bounce back straight. Clear? That will bounce back straight. Clear? So this things we have discussed in our part 1. Today we will start a new thing. New thing. This is what happens when light falls on a mirror. And we will take a plane mirror at first. Then we will take a spherical mirror. So let's start a plane mirror one. Clear? We'll take 2 cases, okay? At first I am taking a plane mirror, okay? Plane mirror, and this is the in part 1 I have discussed that this is the shading behind the mirror, okay? And I am taking another case, 2 cases I am taking, case 1 and the case 2. This is what our case 1, and this is our case 2. Clear? Case 1 I am taking for a point object, dot like object, and point 2 I'm taking like a finite object. Finite object. Clear? Say. Now, few things we have to remember before coming to this. Okay. If I am taking a, also I have discussed about the formation of what object and image. Object from which what light they will emit or they will reflect the light, and image are those which optical appearance which will form after the reflection. Okay. So for incident ray, for real, I have also discussed about that there are two kind of images, real image and the virtual image. Okay. So when in case of any real rays, I will take from an object. We have to know about, this is very important. We have to know before this. Okay. For any real rays from an object, infinite number of ray can come. Okay, after light is falling on me, and after falling, infinite number of light rays can bounce back. But I will take only 2 cases just to keep the diagram simple. Okay, and for any kind of real ray, I will take a full line. And for any kind of virtual ray, I will take the dot line. Real rays are for the rays for front of the mirror, and these dotted rays are for behind the mirror. Now, why this dotted line? Because light cannot travel behind the mirror. Clear? Light cannot travel behind the mirror. That's why I am taking what dotted lines. Okay. Virtual rays. These are the real rays. These are the virtual rays. Real rays are actually existing, but virtual rays are actually not existing. Okay. We are just taking them behind the mirror. Clear? So let's say from an object, infinite number of ray can come. I am taking only 1 ray, or sorry 2 ray. For a ray which is falling straight, normal. So what will happen? It will bounce back straight. Clear? Or I can say a ray is falling obliquely. So what will happen? It will bounce back. This is our incident, this is our reflected ray. Here will be our normal. Clear? Now take another ray. I am taking a second ray which is also falling obliquely. So after falling, it will what? Bounce back. This is our incident ray. This is our reflected ray, and this is our normal. Clear? But for here is an observer, I think, here is an observer, say our eye, human eye say, and I am seeing the object. So what our eye have a nature to see the object in a straight line, tendency. We have a tendency. For example, you are just in front of me, there is a mirror, and any images of yours is forming on that mirror. So I will imagine that the image is behind the mirror. I have a tendency to look the object in a straight line. So my eyes will imagine that the object is placing behind the mirror as a straight. Clear? So see, this is our image will form behind the mirror. Clear? So this is for a small object. So what happens when the object, in case of plane mirror, object from behind the mirror. Clear? Now taken for an second case, take the example for a finite object. So finite for an object, I am taking 2 cases, naming the top of the finite object as A and the bottom of the finite object is what I am taking B. From A, let's say 2 ray can come, a ray falling perpendicularly, another ray say what falling obliquely. Okay? So if it is falling perpendicularly, so it will bounce back. As I have discussed. If this is falling obliquely, so it will what? It will follow the laws of, here also laws of reflection is following. Angle of incident is equal to angle of reflection. Clear? Here what after as it is falling obliquely, so it will make an angle, and it will bounce back with creating the same angle. This is our normal. Clear? So if I draw this line, this will meet at a point behind the mirror. Now I am also taking for the bottom also. From this also a ray can fall and it will bounce back, and take another ray which was falling obliquely, and it will bounce back. If I draw the normal, so what will happen if I increase this line? This will what form? This will meet at a behind the mirror. Clear? Actually, I can't draw because board is so small. That's why I can't exist. Okay. But if I observe, I will see that for a finite object, whatever the size of the object, size of image will be what? Same. For this also, if the image is very small, object is very small, image will be very small. If the object is, for example, my height will be same. So from these 2 cases, we can derive some of the. Now this very important for exam point of view. Okay. Properties or characters. What? Character Acoustics of image formed on plane mirror. Now what is plane mirror? Whose surfaces, for example this board, if this acting as a mirror, then this surface is, if you touch it you will feel this is what, plane. So reflect this, here is reflection is happening, light is falling, or light is falling on this and it will bouncing back, light is bouncing back from this surface. This surface is acting as a reflecting surface. For plane mirror, reflecting surface is what? Plane. Clear? So what are the characteristics of the image that is forming in case of plane mirror? First, image is forming behind the mirror. Image is forming behind the mirror, so its nature is virtual. Nature is virtual, and image is same as the object. Like if I am standing, my image will be also standing, like is me. Okay, so image is virtual and it is erect. Virtual and erect. Virtual and it will not invert. Okay, for this is the pen, then image will be like this, same. Okay, this is what? Virtual, that is behind the mirror it is forming. Okay, light, we have seen that the light is not actually emitting. Our eyes have a tendency to see the object in a straight line. That's why light rays are virtually emitting at a point behind the mirror, not actually emitting. So if they are actually not, as they are not emitting actually, so image is what? Virtual, and same as the object, so it is what? Erect. Clear? Second very important thing is that height of image is equal to height of object. For example, if my height is 5 meter, so my height is 5 meter, then my image height will be also 5 meter. If I am 13 centimeter, my image will be what? 13 centimeter. Whatever the size of the image, whatever the height of the image, same size will be the height of the object. So height of object is equal to height of image. Clear? Now we have also seen that if there is an, for example, behind this board, imagine just this board is acting as a mirror. So there is an image is just who is I'm saying I'm looking at this board, but I will see there is an image of me just behind the mirror. If I come closer to the mirror, that image is also will come closer to the mirror. That image behind me will also come closer to the mirror. That means there is a relation between this object and this what? That image with that what? This surface, plane mirror, for a mirror. So the relation is what? Distance of image from the mirror is equal to the distance of object from the mirror. Clear? Suppose you are standing 2 meter in front of the mirror, your image will form 2 meter behind the mirror. Clear? You are standing 2 meter in front of the mirror. So your image will form what? 2 meter behind the mirror. 2 meter behind the mirror. So we can write as from this we can say that distance of image is equal to distance of object. From here, from the mirror. Now question may come like this. Even for example, a person standing 2 meter, a person standing 5 meter front of the mirror. What is the distance between the image and the object? So if you are standing 5 meter front of the mirror, your image will be what? 5 meter behind the mirror. So image is 5 meter and object is 5 meter. 5 what? 10 meter. Distance of the object and distance of the image is what? 5 meter. But if the question is what is the distance of the image from the mirror, then it is what? 5 meter. If you are standing 5 meter in front of the mirror, your image will be what? 5 meter behind the mirror. And distance between the image and the object is 5 plus 5 ultimately what? 10 meter. Clear? Hope it is clear. Okay. And fourth character was very important. Already I have seen on competitive exam this question. Okay. Plane mirror shows lateral inversion. Now this word is new. Okay, lateral. Let's discuss this lateral inversion word. For example, if you stand in front of a mirror and if you raise your right hand, in your image you will see what? Left hand. But if you raise your left hand, you will see what? Your right hand. That means in case what is happening here, that for object's right is image left and object's left is image right. This incident is called lateral inversion. Clear? And there is a clear case of this. We usually see in case of ambulance. The letter is what? The word ambulance is inverted. So that when the image will form, it will be the driver will see that image is written as what? Ambulance. Okay, clear? So lateral, this are the very important characteristics of what? Plane mirror. And last, these two are very important. Generally MCQ comes from these two. So first character is what? The image is virtually erect. Virtual means what? It is light rays are not actually meeting behind them. Image is forming at behind the mirror, and you cannot place that image on a screen. Clear? We have discussed in part 1. The virtual image, we cannot place that image on a screen. For example, you are seeing an image, but you cannot place that image on a screen. If you take a screen behind the mirror, then you cannot take that image on a screen. So this image is for virtual, not actually existing. Okay, and it erect like the object standing. Clear? Height of the image, whatever your height, your image will be at the same height. Distance of the image from the mirror, behind the mirror, is equal to distance of the object from the front of the mirror. And the lateral inversion means what? That left, right, right, left. Clear? And example we can see in case of ambulance. Clear? So this is all about plane mirror. And any question for if examiner want to give from plane mirror, this will be from this. Clear? Clear? You can make a note or you can take a screenshot of this. Okay. Hope you have taken the screenshot or you have taken the clear. But one thing is that in case of class 10, plane mirror, it usually question not comes from plane mirror. Okay, if somebody wants, they can give 1 mark. It will not usually not comes. Okay. Next is very important. Okay, for class 10, spherical mirror. Spherical mirror. Okay. Let's discuss about spherical mirror. Now, what is spherical? Have you seen any kind of spherical mirror? What is spherical mirror? Let's know first. Spherical mirror are such mirror. For example, let me take one spoon. Okay. If you see, if you want to see your face, if you check, just observe this face. Okay. If I draw this, what will happen? Like this. In this way also, I can see my image forming. That side also, this side, back side also. In inner side also can form an image. Back side also can form an image. Clear? This way also I can. If I see this way, then image will form. If I see also back side, then I will see an image is forming. Okay. But if you say from the inner part, if you see, you will see what image is just inverted. Okay. Image gets what inverted. But if you see this way, image is what? Virtual. Sorry, erect. Same as the object. Okay. So let's know about spherical mirror. Spherical mirror are what? This surface. When I'm talking about plane mirror, this reflecting surface is plane. But in case of spherical mirror, reflecting surface, this part is reflecting. When I'm seeing the inner part of the spoon, inner part is acting at a reflecting surface. But when I'm seeing the outer part is acting as a mirror. If I draw this, if I complete the diagram, what I will see that this surface is a part of a sphere. This reflecting surface is a part of sphere. That means spherical mirror are such mirror whose reflecting surface are a part of sphere. Clear? If you take a spoon and if you draw the diagram, complete diagram, you will see that the image is that spoon, part of spoon is a part of sphere. So spherical mirror are such mirror which looks like part of a sphere. Clear? Hope it's clear. Okay. Now spherical mirror are two types. Spherical mirror are of two types. One is concave. Another is convex. When I've seen my image through this inner part, that means outer part is acting as the shading. And when I'm seeing the inner part, this inner part is acting as a mirror. Inner part is known by the concave part. Inner part is known by the concave part. When in case of spherical mirror, inner part acts, when in case of spherical mirror, the reflecting surface is concave. For in case of inner part, cave like this stuff. This cave. Concave means what? Cave like inner part. Inner part is acting as a reflecting surface. Then the mirror is concave. When you are seeing in case of the outer part, this outer part is acting the inner. That means shading on the inner part. Shading on the inner part. Okay. Shading on the inner part. This outer part is acting as a mirror. When you are seeing through the inner part of the spoon, inner part is acting as a mirror. Reflection is happening on the inner part. When you are seeing the bulging part, outward part is acting as a mirror. Okay. So when the outer part, that means bulging part, acting as a reflecting surface, it is convex mirror. When the inner part is acting as a concave part is acting as a mirror, reflecting surface, mirror is what? Concave. Clear? Hope it's clear. If you see this way, this part is our concave and that part is what? Our convex. When I am seeing this way, this part is acting as a reflecting surface. When I am seeing that way, that part is acting as a mirror. When I am seeing this way, this outer part is acting as a what? Acting as a shading. Okay, silver coating and brown color. Okay, brown paint. When I am seeing the outer part, interior part is shading. Okay. Now let's discuss about some of the terminology, some of the terms, terminology. Some of the terms regarding spherical, which is very important. And if you want to go further, if you want to know further about this chapter, in these points are very important. Terminology regarding spherical mirror. Okay. First point is where, which is what? Pole. First term is what? Pole, denoted by P. Denoted by P. I'm explaining with the diagram. Okay. I'm taking a mirror whose outer part have a shading. That means if the outer part is shading, this mirror is a what? Outer part's reflection will happen at the inner part. Reflection will happen on this part, and reflection is happening in this part. This is a what? Concave mirror. Concave. Hope it's clear. Okay. Concave mirror. Concave mirror. The physics is all about understanding. If you are concentrating, the things will be clear. Okay. Try to focus and try to understand. When the reflection is happening on the inner part. See. Now, what is pole? Pole is the center of the mirror. Center of the mirror. This is the, say our mirror is what? 10 meter long. Okay. This will be the mid center of the mirror. Pole is a point on the reflecting surface of the mirror. It is a point on the mirror. It is the center of the mirror. Whether it is concave, whether it is convex. Clear? Whether the mirror is concave, whether the mirror is convex, no matter what kind of mirror it is, the pole is in the center of the middle of the mirror. And it is a point on the mirror. And it is denoted by P. Hope it's clear. Pole, it is a point. It is the center of the mirror. Okay. And it is a point on the mirror. Hope it's clear. Okay. I'm coming to next point. And the next point is center of curvature. Center of curvature. See, this point will remain same. Whether if you after a 10, if you go in what first or second, if you take science physics, then this point will remain same. Pole, center of curvature. Center of curvature we denote by its what? C. Now what is center of curvature? Okay. Center of curvature. If I take a mirror, I'm taking an example of concave mirror. The outer part is shading. This is our P. This is our P. Pole. Okay. Now we know that this this mirror is a part of a sphere. Part of a sphere. And this sphere have a center. Every sphere, like every sphere, this sphere may have a center. So this center is called center of curvature. Again I was telling, we know that our mirror is part of a sphere. Mirror is part of a sphere, and this sphere and every sphere have a center. So this sphere have a center, and this center is called center of curvature. For concave mirror, center of curvature is at the front of the mirror. For the convex mirror, this is our P. Center of curvature is behind the mirror. Center of curvature is behind. This is very important. For concave mirror, center of curvature is front of the mirror, but for convex mirror, center of curvature is behind the mirror. For concave, center of curvature is front of the mirror, but for convex mirror, center of curvature is behind the mirror. Now this next what I am telling is, center of curvature is not a part of the mirror. It is not a part of the mirror. It is the part of sphere. Whose part is a mirror? Whose part is mirror? It is the part, this center of curvature is a part of sphere, not the mirror. This center of curvature is not a part of the mirror. It is a part of the sphere. Whose part is mirror? Whose part is mirror? Clear? Next point is radius of curvature. Hope it's clear. Radius of curvature. Radius of curvature. Radius of curvature. Denoted by R. Denoted by R. Clear? Now this is very, very simple. We know that our mirror is part of a sphere, and every sphere have a radius. Every sphere have a radius, and this radius is called radius of curvature. For concave it is front of the mirror, and for convex it is behind the mirror. This is the distance between the center of curvature and pole. I am drawing a diagram, okay? Explaining. Let's take a concave mirror and draw a sphere, okay? Actually dot line, if they are not really existing. This is our center of curvature and this is our pole. The distance between the center of curvature and the pole is called radius of curvature. The distance between the pole and the center of curvature is called radius of curvature, and this radius of curvature is also a part of the sphere. This is the radius of the sphere. Hope it's clear. The pole means center of the mirror. It is a point on the mirror. It is a part of the mirror. Center of curvature. Every sphere, mirror is a part of sphere, and their sphere has a center. The center is called center of curvature. For concave it is front, for convex it is behind. Radius of curvature. Every sphere have a radius, and that radius is called radius of curvature. For concave it is front of the mirror, for convex it is behind the mirror. It is the distance between the pole and the center of curvature. Clear? Hope all clear, okay? Now I'm coming to the fourth point. Principal axis. Principal axis. Principal axis. Let's take a diagram of concave mirror. Shading at the outward part. This is the pole and this is our center of curvature. This distance is our radius of curvature. If imaginary line passes through center of curvature up to pole. Imaginary line, not the actual line. This is the imaginary line. Passes through the center up to pole. Up to imaginary line passes through the center of curvature up to the pole. This imaginary line is called principal axis. And remember this point. This line, this principal axis is acting as a normal. Acting as a normal with the reflecting surface. It is the normal. It is the light ray will bounce back straight. In case of now this phenomenon is based on reflection of light. While light is reflected, not what light is falling and light bouncing back. So this principal axis acts as a normal. Clear? Clear? It is the imaginary line through center of curvature up to pole. Hope it's clear, okay? Now next point is very, very, very important for exam point of view. This is principal focus denoted by F. Now for this, say this is our principal axis, this is our center of curvature. In case of concave, I'm taking one example for the concave, another I'm taking for the convex. Okay, for the convex. This is our P. C will be at the behind the mirror for convex. This is for the convex and this is for the concave. Do one thing. Just do after all this. Just go through the book once. Okay, then things will be more clear. Principal axis. So this is our principal axis. Okay. When parallel beam of light. Now this is a new term, beam of light. Ray means when I'm talking about ray, single ray of light. Okay. But when I'm telling about beam, group of light ray. Now this beam of light can be of converging. They are, for example, you are going to school. So all the students are meeting at a point. Okay. Converging. Where all the light rays are meeting at a point. After the bell ring bell, what happens? All the students coming out. They are diverging. So from a point they are what? Getting away. Clear? So when it is converging, they are meeting at a point. When diverging, they are coming out from a point. Okay. And their third is parallel. This is very simple. Okay. Which are never meeting at each other. These three are the beam of light. Can be converging, converge. Can be converge, can be diverge, can be what? diverge can be what? Parallel. Let's take the example for the concave. If the parallel beam of light ray falls, parallel beam of light ray falls, I'm taking two rays, okay? Sufficient. Light ray falls parallel in concave mirror, so after reflection what will happen? This ray will bounce back. This ray of light will bounce back and they will meet at a point. After reflection, beam of parallel ray of light falls on a concave mirror. After reflection, they are meeting at a point on principal axis. Meeting at a point on principal axis. This is the after reflection meeting at a point on principal axis. This point is called principal focus for concave mirror. Now what is happening here? Light after reflection they are meeting at a point. That means converging. That's why concave mirror is also called converging mirror. Converging mirror. As after reflection light ray meets at a point. So as the light ray after reflection meeting at a point, this mirror is also called converging mirror. Okay, and this point where they are meeting is called principal focus for concave mirror. Now let's take the example of convex mirror. What happens if the light ray falls? So convex mirror have a tendency to diverge the light ray. So light ray, what will happen? They will diverge. After falling on the mirror, they will diverge. This happen. From the point they will diverge, scatter away. They will scatter away. Okay. Now if you, as that this ray will never meet each other, they are going away and away. So if even observer sees there, he will think that the point is coming out from a point behind the mirror. That point is principal focus. Bit difficult. Okay. After falling, they are diverging. But the observer here, for example, I'm seeing from this point. So what I will think, I will assume that the point is coming from the behind the mirror. So that point is what? Principal focus for the convex. And this is very, very important. For concave, this focus, principal focus is actually existing. This is real focus. But in case of convex, this is not real. This is what? Virtual. Okay, it is behind the mirror, not actually meeting. I'm assuming that they are coming out from a point. So this is not actually meeting. This is the virtual focus and this is the real focus. Here light is a diverging. That's why convex mirror is also called diverging mirror. Diverging mirror is what? Converging mirror. Light is meeting at a point. After reflection, meeting at a point. Here after reflection, they are going away, diverging, scattering. Okay. Hope it's clear. Okay. This is what? After reflection, meeting at a point. In case of convex, they are diverging, but observer will think that coming from behind the mirror. That point is principal focus. And fifth point is focal length. Focal length denoted by small f. Hope this too clear. Okay. Principal focus. This question very, very important. Define principal focus for concave mirror. Define principal focus for convex mirror. For concave mirror, if light ray falls on mirror after reflection, they will meeting at a point at the principal focus. This point is called principal focus. Okay. After when light ray falls, parallel beam of light ray falls on convex mirror, they will diverge away. But they will seems to be appear at a there seems to meeting at a point behind the mirror. That point is principal focus for the convex mirror. Clear? If you read the book, then it should be clear. Okay. Try to read the book. Focal length. Last point. This is the distance between the pole and the principal focus. This distance between the principal focus and the pole. Principal focus F. Distance between the F and P. F for principal focus, capital F, and the P for pole. This distance between the F and P is called focal length. Hope it's clear. It is the distance between the principal focus and the pole. Clear? Okay. For concave it is front of the mirror. For convex it is behind the mirror. Okay. For sine convex this is very important. Where the focus is lying, it is front of the mirror, it is behind the mirror. For sine convention later we will discuss. Okay. Hope it's clear. If you draw the diagram, then draw the diagram once. Okay. Hope this will be clear. Take a screenshot or draw the diagram. Hope things will be clear. My handwriting is bad. Okay. Don't try to cover up. But do one thing. Just read the book. Okay. Go through the book. And the last part of today's discussion. After this, we'll end the discussion. I will give one number and description link, and you can do one thing. Just you can message me on that number. I will provide the question regarding this. Okay, the discussion. Okay. The relation between relation between R and F. R and F. Now, if you're not understanding what is R, what is F, just do one thing. Pause the video and back. Okay. R is our radius of curvature. Radius of curvature. Radius of curvature. And F is our what? Focal length. Focal length. I'm taking a example of concave mirror. Don't get panic. I'm taking example of concave mirror because this is very, very important. Convex mirror usually not comes in exam. Okay. This is the principal axis. This is our center of curvature. This is our pole. The distance between the C and P is called center of curvature, and pole is called radius of curvature. And say this is the focus. The distance between the F and P are called the focal length. Now clearly from this diagram you can say that what is the relation, that this is our R. This is our R means radius of curvature, and this is our focal length. This is our focal length. Clearly from this we can see that we can derive the we can tell the what is the relation. The relation is what? R is double of F. That means R is double of F. R is double of F. This is the relation. Radius of curvature is the twice of focal length. Twice of focal length. And F is the what? F is the half of R. Half of R. That is what? R by 2. R by 2. This formula is very, very important. Focal length is the half of radius of curvature, and radius of curvature is the double of focal length. F for focal length, distance between the pole and the principal focus, and C R for radius of curvature. That this is a relation. F equal to R by 2 and R equal to twice of. Several questions may come from this. Say in case of concave mirror, if the radius of curvature is 30 cm, what will be the focal length? So if the radius of curvature is 30, that means R is 30. So what is F? F equal to R by 2, 30 by 2, that means 15 cm. Say in case of convex mirror, focal length is 10 cm. Focal length is 10 cm. What will be the radius of curvature? If the focal length is 10 cm, 10 to the 20 is our radius of curvature. Clear? Hope all of this clear. So these are the terminology. These are the terms. These are the terms which are very, very important to learn about what spherical mirror. Whatever you learn in this chapter regarding the spherical mirror, these terms will come. Every point, these terms will come. The first is pole. Pole is a point on the mirror. It is the center of the mirror. Second, center of curvature. Every mirror have a sphere. Every mirror is a part of a sphere. That sphere have a center. That center is called center of curvature. For concave it is front. For convex it is behind. Then there is a third point, radius of curvature. This sphere have a radius. This radius is called radius of curvature. It is the distance between the center and the pole. Center is center of curvature. Pole is our pole. Clear? Then there is a principal axis, imaginary line passing through the center of curvature and a pole. Okay, and this acting as a normal. Acting as a normal. Clear? Then there is principal focus. Very, very important. Principal focus is the most important one. Okay. Principal focus, parallel beam of light falls on a concave mirror. They are after reflection meeting at a point. So they are converging light rays meeting at a point. That point is principal focus. And for convex, parallel beam of light falls and they divert the light rays. They assume to meet at a point behind the mirror. That is what? For convex, for focal length, focus for the convex. For concave, focus is actually real focus, but for convex it is what? Not real. Okay, virtual. This is. Then we have learned about focal length, distance between the principal focus and the pole. Then we have learned relation between the R and F. And this is our part number 2 of light refraction and the refraction. Tomorrow we will discuss about image formation in mirror. We'll discuss about how image forms in case of concave mirror and how image forms in convex mirror. Okay. Hope the discussion is clear. And do one thing, just share with your friends, and so that more number of together we can achieve best. Okay. So share with your friends and subscribe my channel and share the press the bell button. Okay. Thank you so much. Hope you will enjoy the video. Okay. Good luck.